Today we're going to learn about the laws of logarithms. So since a logarithm simply represents an exponent, each of the exponent laws that you learned about in Math 9, when you're multiplying the same base, that you add your exponents, when you divide the same bases, you subtract your exponents, and when you have a power being raised to another power, you actually multiply your exponents. Each of those can also be written in logarithmic form, okay? So it's the same thing as when you multiply two of the same base and you add the exponent. The log of a product, so when you're multiplying two logs in the same base, and you see the multiply sign, that's equal to the sum of those two logs. So you take each log separately and you add them together, just like you added the exponents when you were multiplying with exponents. When you divide with exponents, you subtract the exponents, as long as you have the same base. The same thing with a log. If you have a log of two numbers and they're in the same base, these are both in base 2, then what you would do is just subtract those two logs. So the log in base 2 of 8 minus the log in base 2 of 4. And same thing when you were raising a power to a power and you multiplied the exponents. Then if you're doing it in logarithmic form, the log of a power is equal to the product of that power and the log. So this exponent would actually be brought down in front and multiplied 2 times log in base 2 of 4. Okay? So we're going to try a few of these, and I think once we do a few, you'll see really how straightforward this is. So if we have log in base 3 of 9 times 3, we're going to apply the product law, which says that's the same thing as log in base 3 of 9 plus log in base 3 of 3. Okay, and on our calculators, we would evaluate each log separately. So if you remember on your calculator will only calculate logs in base 10. So this is in base 3, so you'll have to use the change of base law, which says you'll go log 9 divided by log 3. When you plug that in on your calculator, just don't forget to close your bracket and go log 9 divided by log 3 and hit enter, and it tells you the answer of that is 2. Now you could have really done that in your head because you know that a log equals the exponent, right? It isolates the exponent. So what you're saying to yourself when you do this without your calculator is 3 raised to what power would give me an answer of 9? Well, 3 squared would give me an answer of 9. Okay? That's what a log is. Okay, so if we did log 3 of 3, if you plug this in on your calculator, log 3 divided by log 3, well, I think right away you can see what's going to happen there. Whenever you have something divided by itself, the answer is 1, right? So log 3 of 3 is 1. So this log 3 of 9 times 3 is equal to 2 plus 1, which is 3. Okay, let's see if we can apply the product law backwards this time. We were using it here. It was one single log, and we were expanding it and turning it into 2 separate logs. This log and this log. Okay, in this case now we have 2 separate logs, and we're being asked to combine them into one single log. Okay, but we're going to use still the product law because we know when we have 2 logs in the same base and they're being added together, that's the same thing then as log in that base, which was base 3, of 9 times 3, which would be log in base 3 of 27. And if you plug that in on your calculator, you'd plug log 27, close your bracket, divided by log 3, and it gives you an answer of 3. Again, you could have done that in your head and just said 3 raised to the what power will give me an answer of 27. 3 cubed gives me an answer of 27. Okay, log in base 3 of 9 divided by 3. We're going to use the quotient law in the box above. And the quotient law says then that this is the same thing as log in base 3 of 9 minus log in base 3 of 3. Just like when we are dividing two of the same base with their exponents, we subtract exponents. Now we're dividing two in the same base, and so we're subtracting their logs. Okay, log 3 of 9, well, we figured that out right here. It was 2. Minus log 3 of 3, well, we figured log 3 of 3 out there. It was 1. So it's 2 minus 1, which is 1. Let's see if we can apply that that quotient law the opposite way. We are now going to use it to combine these two separate logs into one single log. And it's the exact same thing though, because I noticed that both logs are in base 3 and they're being subtracted. That's the same thing as writing it this way, log in base 3 of 9 divided by 3, which is log in base 3 of 3. And we know log in base 3 of 3 because we figured it out here and here. It is 1. All right, the last one on this page is log 3 of 3 squared. Okay, this is where I'm going to apply the product law, which means this little 2 will come down in front and be multiplied in front of log in base 3 of 3, which means 2 times, what was log 3 in base 3? 1, right? 2 times 1 is 2. Okay, now I can apply this law the other way. When I see the 2 in front of a log, I can just bring it up here as the exponent. That's the same thing as log 3 of 3 squared, right? I'm going to put that 3 in brackets to show that it's that 3 that's squared. That's log in base 3 of 9. And I can either plug this in on my calculator, log 9 divided by log 3, or I can just say 3 raised to what power would give me an answer of 9. 3 squared would give me an answer of 9, right? So that is my final answer. Okay, so there is a summary at the bottom of your page that you should highlight or star because this summarizes those 3 laws of logs: the product law, the quotient law, and the power law. And these are laws that you just have to know how to use. They are on your formula sheet. You don't have to memorize them, but you do have to know how to use them. Either to take 2 logs and combine them into 1 log, working that way, or going the other way where they give you 1 single log and you have to use them to expand into 2 separate logs, working that way. Okay? So when you are multiplying 2 numbers and they are to the same base, then you just rewrite it, expand it as the sum of those 2 logs in the same base. When you are dividing 2 numbers in the same base, then it's the same thing as subtracting their logs. And when you have a power on a base, you bring that power down in front and multiply it in front of that log. Okay? And just remember this, when you see the root of m, that's the same thing. For instance, if it's the square root of m, then that's the same thing as m to the half. If it's the cubed root of m, that's the same thing as m to the 1/3. Okay, so that number, whatever that is your index here, is coming down in front to multiply in front of the log, is what that is saying. Okay, all right, so let's try a few examples on the next page. It just tells us here at the top of the page that the laws of logs are used in a variety of ways, and we've talked about some of those ways already. Sometimes we use them to simplify an expression. If it gives us, for instance, this, 2 logs, and it asks us to write it as a single log, we're simplifying it. We're taking those 2 logs and putting them into 1. Okay? Sometimes, though, it asks us to work the other way, and it'll give us 1 single log, like it does down here at the bottom of our page, And it's asking us to expand the expression. In other words, write it as 2 logs. And then sometimes it asks us to evaluate the expression. That means come up with a value. You can see that word right in the word evaluate. Come up with a value. X equals what, for instance, okay? Or sometimes it's used to rewrite an expression in terms of the data that's provided, okay? So we're going to look at a variety of uses of laws of logs. The first one says we have log in base 2 of 17 plus log in base 2 of 5. Okay, well what I notice first of all is they're both in base 2. I can't use a law of logs if they're not in the same base. But because they're both in base 2, this is the exact same thing as saying log in base 2 of 17 times 5, which is log in base 2 of 85. If I calculate that on my calculator, 17 times 5 is 85. Now, this is all this question is asking me to do. It is not asking me to evaluate. If it said evaluate, I would have to plug in my calculator, log 85 divided by log 2, and get an actual value. This is just asking me to express it as a single log, which is what I've done here. This has taken 2 logs and turned it into one single log. That's all I had to do, using laws of logs to do that. Okay, let's try this one. We've got 2 logs again. They're both in base 5, so I know I can combine them into one log in base 5. This is the same thing as log in base 5 of 12 times 3, which is log in base 5 of 12 times 3, 36. And that would be my final answer. I've combined 2 logs into one single log. Log in base 4 of 50 minus log in base 4 of 5. Well, they're both in base 4, so I can combine them into one single log. And when it's subtracting, that's the same thing as dividing 50 divided by 5, okay? Which is log in base 4 of 10. Yes, that's my final answer. Log in base 5 of 24 minus log in base 5 of 3. Well, they're both in base 5, so I can combine them into one single log. 24 divided by 3, which is log in base 5 of 8. Right, I hope you said 8. Okay, now this one looks a little bit different, but it's the exact same thing. I notice that they are both in the same base. What is the base in this case? There's no number written there as a base. When there's no number written there as a base, it is base 10. That's right. Okay, it is assumed that it is base 10 if there's no base indicated. So this is the same thing as they're both in base 10 and they're being added. So that's the same thing as this times this. Oh, look at that. It's 2 binomials that I'm going to have to multiply. Okay, so I'm going to have to expand this to figure out what this is. So I've got x times x squared, x times negative 2 minus 2x, x times 1 plus x, 1 times negative 2 minus 2. Okay, and if I took this a step further then and combined my like terms, this is the same thing as log in base 10, I don't have to write that, of x squared, negative 2x plus x is negative 1x minus 2. So this would be my final answer. Okay, and then I have one more similar to that, but this time both my logs again are in base 10, but this time it's being subtracted. Okay, so this tells me this is a quotient, right? So this is the same thing as log in base 10 of x minus 1 over x plus 2. And I would just leave it like that, because now I've taken those 2 logs and combined them into one single log. All right, the next set of examples says express the following as a single log and evaluate without using a calculator. Okay, it does want me to evaluate. That means I need to have an answer in the end. This equals 10, for instance, or whatever it is. Okay? So express as a single log. Right now this is two separate logs, so I need to express this as one single log. This is the same thing as saying log in what base? Right, log in base 10. So this is log in base 10 of 100 plus log in base 10 of 1,000, right? And in my calculator, this is one that my calculator will evaluate because it's in base 10. So I don't have to plug it in an unusual way. I just need to plug it in as log 100. Now, probably you can do this in your head without even having to plug this in on your calculator. Before I push enter, let's just see if you can figure out what it would be. Base 10, so 10 raised to the what power gives me an answer of 100. 10 squared, right? Okay, if I hit enter, I should get the same thing. Okay, so let's use that same thing then. 10 raised to what power would give me 1,000? Hopefully you didn't need to use your calculator to say 10 cubed would give me 1,000. So this is the same thing as 2 plus 3, which is 5, right? And then it says evaluate. That's what it means. I need an answer in the end. Equals 5. Okay, let's try this one. Log 3 of 81 times 27. This is the same thing as log 3 of 81 plus log 3 of 27. Okay, so in your head or on your calculator, 3 raised to the what power gives me 81. So you can plug that in as log 81 divided by log 3. Or if you could do it in your head, 3 raised to the 4th power is 81. Okay, so log 3 of 81 is 4. Log 3 of 27, 3 raised to the what power is 27? 3 times 3 times 3, right, 3 cubed. So that gives me an answer of 7. Log of 1,000 divided by 10. Okay, well that's the same thing as saying log in base 10 of 1,000. And because it's dividing, it means we're going to, what did we do with exponents? Subtract, so we're going to subtract these two logs, right? Log in base 10 of 10. Okay, we did figure out log of 1,000 up here. We've already got it right here. We figured it out. It was 3. So that means this is 3 minus log 10 of 10. 10 raised to the what power gives me 10? 1, right? 3 minus 1? 2. Okay, log in base 5 of 1 over 25, that's the same thing as log in base 5 of 1 minus log in base 5 of 25. Okay, let's think this through in our head. 5 raised to the what power is going to give me an answer of 1. Okay, hopefully you have your answer in your head. Let's do it on our calculator just to double check. Log 1 divided by, oops, to bring this a little more over here, divided by log 5 Have you got your answer before I hit equals? 5 raised to the what power gives me an answer of 1. 0, right, okay. And this one, 5 raised to the what power gives me 25? Squared, right. 0 minus 2? Negative 2. Okay, log of 25 plus log of 4. Let's see, those are both in base 10. So that means I can take them and combine them into 1 log of 25 times 4. Right? If they're being added, that's the same thing as the product law. Right? So this is log of, what's 25 times 4? 100. We've already figured out. Base 10, right? So 10 raised to what power gives me 100? Power of 2. 10 squared is 100. Okay. log in base 3 of 2.7 plus log in base 3 of 10. That's the same thing as log in base 3 of 2.7 times 10, which is log in base 3 of 27, which means 3 raised to the what power is 27? 3 cubed, right. Okay, log in base 7s, they're both log in base 7. This is a difference, so this means I'm actually dividing. So this would be 490 divided by 10, which is log in base 7 of, what's 490 divided by 10? 49, and I can think you can see where this is going. 7 raised to what power is 49? Right, squared. Okay, last one. Log in base 5 of 15 minus log in base 5 of 3. That's the same thing as log in base 5 of 15 divided by 3, which is log in base 5 of 5. Have you noticed a pattern when we have the same base and the same number? This would be like log 5 divided by log 5. When we have a fraction where we have the same numerator and the same denominator, it's always, always, always equal to? Right. You could plug it in on your calculator if you wanted, but you really don't need to. Okay, we're going to do a few more on the next page, and then you're going to have a chance to try some on your own. Log in base 6 of 9 plus log in base 6 of 8 minus log in base 6 of 2. Sometimes there's more than just 2 logs, and you follow the same laws of logs that we've been doing, following the rules of BEDMAS, working from left to right. So let's just make ourselves a note of that right at the top of the page. Okay, follow rules of BEDMAS. So what that means is if there are products or quotients, you would do them first. Well, if there were exponents, you would do them even first. And then multiplication and division, and then addition and subtraction, okay? And working from left to right. So if you have, in this case, the reason we say that is because in this case you have an addition and a subtraction, and those are equal operations as far as BEDMAS is concerned. Addition and subtraction, you do in order, whichever one comes first as you go from left to right. Same if you had 2 that were multiplication and division, you would do whichever one comes first in order from left to right. Okay. Okay, so let's give this one a try. We see that we have all 3 in base 6, so we can combine them all into one single log, which means log in base 6 of, this would be 9 plus 8. That tells me that's a product, so on the top it'll be 9 times 8, and it's being then subtracting logs in base 6 of 2, which means we would be dividing by 2. This is the same thing as saying log in base 6. Now you would evaluate what you have in brackets here. So 9 times 8 is 72 divided by 2. So that's the same thing as saying log in base 6 of, what is 72 divided by 2? 36. And so then in your calculator you would plug in log 36 divided by log 6. Or you can just ask yourself 6 raised to what power gives me an answer of 36? The second power, 6 squared. Okay, so see how that works? We can combine them all into one single log. Let's see if we can try this one. Again, we have equal operations. We have a subtraction and an addition, and so they're equal. So we're just going to do them in order from left to right. They're all base 2, so I can combine this into one single log in base 2. So this will be 48 divided by 12. And then I'm going to When it's an add, that means times by 4. So this is log in base 2 of, what is 48 divided by 12? 4. And so I have log in base 2 of 4 times 4? 16, which is 2 raised to what power gives me 16? You can do it on your calculator if you choose. 4. Okay. Now I have 4 logs. They're all equal operations. I've got adding, subtracting, adding. Okay? So I'm just going to go in order from left to right. And they're all in base 2, so I can combine them all into one log. So this is 2 times 3. I'm going to be dividing by 6. And then I'm going to be timesing by 8, yes. Okay, so log in base 2 of 6 divided by 6, that's 1. So this is log in base 2 of 8, which if you think about it for a minute, 2 raised to what power will give you 8? 3, right. Okay, let's try this one. Now we do have brackets in this one. And what that means is I need to do, according to BEDMAS, I need to do brackets first, okay? So I'm going to just leave the rest of this for a minute. Log in base 2 of 2 plus log in base 2 of 3. And then it's minus whatever this ends up being, okay? So log in base 2 of 6 plus log in base 2 of 8 is the same thing as saying log in base 2 of 6 times 8, right? Okay. So we've got log in base 2 of 2 plus log in base 2 of 3 minus log in base 2 of 6 times 8 is 48. Okay, so now I'm going to put this in one single log. So that's log in base 2 of, my numerator I'll have 2 times 3, and my denominator I'm subtracting now, so on the bottom will be 48. This is log in base 2 of 6 over 48, which is log 2 of 6 divided by 48 in lowest terms would be 1/8. So this means 2 raised to the what power gives me an answer of 1/8. Well, on your calculator, you may have to enter this into your calculator. So we can go log of 1/8, and it is in brackets already, 1 divided by 8. Oops, and get my divide sign. And then divided by log 2. Don't forget to close your bracket and hit equals. -3. So that means 2 raised to the power of -3 equals 1/8. And that makes sense because 2 raised to the -1/3 is the same thing as 1 over 2 to the 3rd, which is 1 over 2 to the 3rd is 8, right? Okay, so that all makes sense when you think about it. You can double check your work that way. Okay, now there are some questions where we have the power law and then some combinations questions that we're going to try before you have a chance to practice some on your own. So the first set asks us just to use the power law to rewrite the following. And so what that means is if we see a number here in front of a log, we bring that up as the power. So this is the same thing as writing log in base 3 of 5 squared. Okay? And so that really means log in base 3 of 25. And it does ask us to evaluate, which means we need to find the value. So then on my calculator, I will punch in log 25 divided by log 3, and I will get an answer, 2.93. So you can see that logs are not always whole numbers. Sometimes you'll have a fraction answer. Okay, in this case, we're bringing 2/3 up as our exponent, so this is the same thing as log in base 9 of 27 to the 2/3 power. Okay, so if you calculated what is 27 to the power of 2/3, on your calculator you would just go 27 raised to the power of, and then bracket 2 divided by 3, 2/3. And when you hit enter, it tells you that 27 raised to the 2/3 is actually 9. So this question is saying log in base 9 of 9. And if you remember before, we discovered that when we have the same base and the same value, that's the same thing as saying log of 9 divided by log of 9, which is an answer of 1, right? Whenever those two are the same, your base and your number, then it equals 1. Always, always, always. Okay, we have 1 over x times log in base p of y. So again, we just bring our 1 over x over here as our exponent. So that's the same thing as log in base p of y to the 1 over x. And this is why it says evaluate if possible, because there's no way we can evaluate that one. You would have to just leave it like that because we don't know what any of those variables stand for. Okay, this one we have 3 times log xy. Okay, well, we have a few different things going on here, and this is why this section is called combination questions, because I notice I have a 3 times this, but I also notice that I have a product here, x times y. Okay, so I need to do a couple different things to expand this. So for now, I'm going to just leave this 3 out here. This log of x times y is the same thing as log x plus log y. Now, if I multiply that 3 in there, I've really got 3 times log x plus 3 times log y. And now if I use the product law, or sorry, the power law, it's going to bring that 3 up as my exponent, isn't it? So that's the same thing as log of x cubed plus log of y cubed. And that would be my final answer. Now, a different way to do this question is I could have brought this 3 up as my exponent right off the bat. And if I had done that, I'd have log of x cubed, y cubed. But I still see that I have a product here. This is x cubed times y cubed. So that's, again, the same thing as log of x cubed plus log of y cubed. And I'd have the exact same answer I got there. So it doesn't matter which way you apply them, as long as you apply every law of logs that you can apply until you can't apply anymore. Okay, a times log x plus a times log y. Okay, well, I'm just going to apply the power law, which says I would bring the a up. So to be log of x to the power of a times log of y to the power of a. And then because I have 2 logs, both in base 10, then I can combine them. That's the same thing as oops, sorry, my sign was wrong here. This should have been a plus, because all I did was apply the power law here, where I brought the a up as my power. Now I'm applying the product law that says when this is a sum, I'm multiplying those logs. Okay, the next one, 2 times log of x minus 1. Okay, so I'm going to bring my 2 up. So this is the same thing as log of x minus 1 squared. Well, I know right away that means I'm going to have to expand that. X minus 1 squared is the same thing as x minus 1 times x minus 1. And then I have to multiply that out, and that's x squared minus 1x minus another x plus 1. So in final terms, this is log of x squared minus 2x plus 1. Okay, negative 5 times log of x divided by 3. So I'm going to bring up my negative 5 first. So this is the same thing as log of x divided by 3, all raised to the power of negative 5, which really means when I have a negative exponent, negative 5, just like before, when I had 2 to the negative 3, it was the same thing as 1 over 2 cubed. It's the same thing here. Because I have a negative exponent, it's the same thing as flipping, taking the reciprocal of x over 3. So it's now going to be 3 over x to the 5th power. So what this really means, if I expand this now, is log of 3 to the 5th power divided by x to the 5th power, which, because I have two logs in the same base and they are a quotient, this is the same thing as saying log of 3 to the 5th minus log of x to the 5th. And I can evaluate part of this. I can evaluate the 3 to the 5th part on my calculator. 3 raised to the 5th power is 243. And the rest, log x to the 5th, I cannot evaluate, so I just leave it like it is. And that would be my final answer. Okay. So first I had to deal with this negative exponent by flipping and using the reciprocal. And then once I had that, then I could apply the quotient law of logs and turn it into a subtraction. And then I could evaluate the part that could be evaluated. Okay, and this last one on this page, log of x squared plus log of x to the 4th. Okay, well, I could do this a couple different ways. I'll show you a couple different ways to do this one. One way I could do it is by bringing those exponents down in front. So that's the same thing as saying 2 times log x plus 4 times log x. 2 log x plus 4 log x is 6 log x. Just like 2a plus 4a is 6a, right? And 6 log x is the same thing as log x to the 6th, the exact same thing, right? And this is how I would leave it. The other thing I could have done is right from here, when I noticed that it was both base 10 and they're being added, then that's the same thing as, in a different color, it's the same thing as log of x, and then I would add my exponents, which is x to the 6th, which is the exact same thing I got there, right? So there's ways to check it using what you know about laws of exponents and laws of logs. Okay, there are 2 pages following this that are the assignment for this lesson. In your book, it's page 17 and page 18. I would like you to try those, to work on those and have those done before you come back from the break. I will just tell you that the answers are all on the website, so if you are stuck, you can look there and see where your mistake is and hopefully figure out what you've done wrong. But hopefully that gives you a good understanding of how to apply the laws of logs, and you'll be able to do it. Just remember to follow the laws of BEDMAS. Do it in order of operations, working from left to right, and just keep using laws of logs until there isn't one that you can apply any further. For sure, make sure that you get page 17 and page 18 finished up to here. I will tell you these last two questions on page 18 are quite tricky, but give them a shot and try them and see how you do with them. Check them on the website, but for sure get done up to that blue line before you come back from the break so that you are ready to move on.